Hello guys, welcome to another mathematics video, and today we're talking about integrals. And the goal of this video is to define the integral and specifically the indefinite and the definite integrals, and to make you a little bit less intimidated, in case you are, by the somewhat confusing symbols and formulas that you see around. First, we start by defining what an integral is. And if you're familiar with the Riemann sums video that we did, this should look somewhat familiar to you. However, if not, I'll give a brief rundown of what we're seeing here. And in case of Riemann sums, we're taking rectangles of equal length or equal width, and we calculate the length on either the left side or the right side. And then we find the area of those rectangles and add them together. And this gives us the area under a curve with an underestimation in this case. However, if our curve was descending and we were using left Riemann sums, we would instead get an overestimation. So either case, it's not that accurate and a bit tedious, to be honest, as you increase the number of rectangles, since this is just n equals 4. However, here we have n equals 10, and well, who wants to calculate that, right? So there's a much simpler way to calculate integrals, less tedious, and also something that most people use. So normally you would use integration techniques. And first we have to define the integral, and you can see that with n equals 4 we have a huge error, those large triangles that would actually make our area inaccurate. And as n increases, this starts to look more and more and more as the area under the curve. So one has to ask, what would happen if there were an infinite number of infinitesimal rectangles all throughout this section here from A to B? Then what would be the area? And nobody would want to calculate that by hand, right? But we know now, thanks to a lot of prominent mathematicians, that when our n increases to infinity, the limit actually becomes the definite integral from A to B, and it gives us the area under a curve, which we do not, fortunately, have to calculate by hand. So you should know by now that this is the symbol for integration, and we put our lower boundary below and our upper boundary above, and this is our integrand, so the function we're finding the antiderivative of. And we'll touch on that relationship between the derivatives and the integrals in our video on the fundamental theorem of calculus. However, for now, we will just sort of give a broad view of what an integral is, and specifically the two different types of integrals, the indefinite integral and the definite integral. Now, we'll start by examining the indefinite integrals, and you have pretty basic stuff here. You got the integral symbol, you have the integrand, which is in our case x squared, and what you see here might be a little more confusing, but do not worry, this is quite straightforward. So to calculate the integral, the actual thing we have to do is to calculate the antiderivative first. And this is not as confusing as it sounds. All we have to do is to come up with a certain function that, when differentiated, will give us our initial integrand, or x squared. And x cubed over 3 in this case does just that. If we were to differentiate that, we would get 3x squared over 3, or simply x squared. So voila, that gives us the antiderivative of x squared. And do not worry, you do not have to figure out the antiderivative every time you're trying to find the integral. You simply use the tables, because it has been done a million times before, and probably you will learn those things by heart as you do more and more integration. So, and another very important thing is that we must add a constant, because when we're differentiating, we're getting rid of the constants and there's no way to recover them. They're lost to time. We only know that there used to be some constant, and it could have been the original function, could have been x cubed over 3 plus 10 or x cubed over 3 plus 5,000. It's unknown and unknowable. However, we just have to put this constant here to, you know, sort of remember about it and have our function be more complete. So now we're going to talk about the definite integral, and it's pretty much an extension or a more specific case of the indefinite integral, where we have the lower and the upper boundary for which we calculate the area. And we do this by plugging in first the upper boundary and then the lower boundary into our antiderivative, and then finding the difference between the upper and the lower boundaries. So in this case, you can see this gives us 9, this is 1 over 3, and we get the area of 8.66. And that would be the area under a curve of 3x cubed over 3 from 1 to 3, right? So this is how you find a definite integral, and really nothing complicated. Probably the most tricky part is finding the antiderivative, which you will also learn to do in our other videos. Thank you very much for watching. Hopefully you've learned something new, and I'll see you soon. Bye-bye. Hope you guys like this video. Make your math geek happy. Subscribe to our channel.